Start with the square whose side length is equal to 1 meter. Construct a circle that passes through a corner of the square and is tangent to the opposite two sides of the square. Shade in the following regions. These are the regions that are contained by the circle and the square, but not common to both shapes. The question is, what is the total area that is shaded in blue?
The problem specifies that there is a square with a side length of 1. Overlapping this square is a circle which is tangent to two of the adjacent sides and passes through a corner of the square. Our task is to find the area of the shaded region. We will draw the diagonal of the square. We know that the axis of symmetry of the figure is right along the diagonal. This means that the centre of the circle will be somewhere along the length of this diagonal. We can apply the Pythagorean theorem to the following right-angled triangle to determine the length of the square's diagonal, which we will call d. According to the theorem, the square of the diagonal d is equal to the sum of the squares of the other two sides. Since both sides of the square are 1, this gives us d squared equals 1 squared plus 1 squared, which equals 2. Therefore, the diagonal of the square is equal to the square root of 2. Now, we can draw the following radii of the circle. We will apply the Pythagorean theorem to the right-angled triangle formed to find the value of the hypotenuse x. The legs of the triangle are radii of the circle, so x squared equals r squared plus r squared, which simplifies to 2 times r squared. From this relationship, it follows that x is equal to r times the square root of 2. We also know that the line connecting the centre of the circle with the corner of the square is the radius of the circle, r. It can be observed that r added to x forms the length of the entire diagonal of the square. Therefore, we can say that r plus x equals d. We have calculated d to be the square root of 2, and we have expressed x in terms of the circle's radius r. Substituting these values into the formula, we get r plus r times the square root of 2 equals the square root of 2. We can factor out r, and by separating the terms, we get that r equals the square root of 2 divided by 1 plus the square root of 2. Further simplifying the relationship, we can arrive at the expression r equals 2 minus the square root of 2. We therefore know that the radius of the circle is 2 minus the square root of 2. Next, we can draw two parallel tangents at the points where the circle intersects the square. By drawing a line perpendicular to the two tangents and passing through the centre of the circle, it can be observed that this line represents the diameter of the circle, which is equal to 2 times r. Since the figure has an axis of symmetry, the following two sides will be equal to each other, and we'll call them L. We can apply the Pythagorean theorem to the next right-angled triangle, which has a hypotenuse of 2r, and the legs are L. By applying the theorem, we find that the square of 2r is equal to the sum of the squares of L, or 4 times the square of r is equal to 2 times the square of L. From this relationship, we can determine the value of L to be the square root of 2 times the square of r. The area of the red triangle will be half of L squared. Substituting the value of L in the formula, it will be r squared. We can also calculate the area of the half circle represented in orange. This area will be half of pi times r squared. We can add the areas of both shapes, and the cumulative area for both figures will be the following. Now that we know the missing area, we can write a relationship for the green area we want to calculate. It will be the area of the square with side 1 added to the area of the circle, from which we subtract twice the blue area that needs to be eliminated. The area of the square is 1 squared, the area of the circle is pi times r squared, and the area of the blue figure was calculated above. Simplifying, we get 1 minus 2 times r squared. Replacing the value of r with 2 minus the square root of 2, we get 1 minus 2 times 2 plus the square root of 2 squared. After further calculations, we obtain the area value to be 8 times the square root of 2 minus 11.
Many students find this problem to be challenging, so let's work through it step by step. shade in the common area between the two shapes. Now we want the area that's shaded in blue. That will be equal to the area of the circle plus the area of the square minus 2 times the overlapping area. Furthermore, construct the following right triangle. Since we have an inscribed 90-degree angle, the arc that it subtends will be a 180-degree arc. Therefore, the hypotenuse of this right triangle is the diameter of the circle, which means that this is a semicircle. So we can replace the region that's overlapping by the area of the triangle plus the area of the semicircle. So we'll substitute those in. From here, we have 2 times the area of a semicircle, and that will exactly cancel out with the area of the circle. So now we have a simple equation. The area that's shaded in blue equals the area of the square minus 2 times the area of this right triangle. So let's calculate the area of this right triangle. Start with the center of the circle. Then each of these will be a radius of the circle. This will also be a radius of the circle. Now we have 2 congruent triangles here, which will each be 45, 45, 90 right triangles. So each of their hypotenuses will be r times the square root of 2. Now construct a line between the tangent point and the center of the circle. This will also be a radius of the circle. Do it for both of the tangency points. We now have a square, and the diagonal of this square will have length equal to r times the square root of 2. We can now consider the diagonal of the square with side 1. This diagonal will be equal to the square root of 2, but it's also equal to r plus r root 2. So we have r plus r root 2 is equal to root 2. We can carefully solve this equation for r. Now we can multiply by the conjugate to simplify a little more. So we get r is equal to 2 minus root 2. We're almost there. The area of the square is equal to 1 squared. The area of the triangle will be r root 2 multiplied by r root 2 all over 2. This simplifies to be r squared. We substitute these in, so the area we want is 1 minus 2r squared. We've solved for r already, so we substitute in. We then just carefully need to simplify, and we get the answer of 8 root 2 minus 11 square meters, and that's approximately equal to 0.314 square meters. And that's the answer.